Hi dear students, today we will be discussing surface chemistry. So, surface chemistry is the 5th chapter in 2nd PUC textbook. Now, what do you mean by surface chemistry? Surface chemistry is the branch of physical chemistry that deals with the phenomenon that occur at the surface or the interface. See here, for example, I will take solid . This is solid and liquid gas. So, here there is a surface in solid. See here, this is the surface in solid, and in liquid also there is a surface. Here liquid alli kuda surface ide, but in case of gaseous molecules there will be no surface, no interface between the gaseous molecules. Therefore, only solid liquid surface will be there, solid surface will be there, solid gas surface will be there, but there is no solid, so there is no gas surfaces. So, in this surface chemistry there will be so many phenomena that occur. So, normal life alli navu tumba phenomena na navu nodtivi surface chemistry, surface chemical reactions na. Example ನೋಡಿ ಈಗ ರಸ್ಟಿಂಗ್ ಅಂದರೆ ಕರೋಷನ್. ಕರೋಷನ್ ಅಂದರೆ ಏನು? ಐರನ್ ರಾಡ್ ಇರುತ್ತೆ, ಐರನ್ ರಾಡ್ ಮೇಲೆ ಸರ್ಫೇಸ್ ಡೆಪಾಸಿಟ್ ಆಗ್ತದೆ, ಅಂದರೆ ಇಂಪ್ಯೂರಿಟೀಸು ಡೆಪಾಸಿಟ್ ಆಗ್ತದೆ ಆ್ಯಸ್ ಐರನ್ ಆಕ್ಸೈಡ್. ವೈ ಕರೋಷನ್ ಅಕ್ಕರ್ಸ್? ಕರೋಷನ್ ಅಕ್ಕರ್ಸ್ ಬಿಕಾಸ್ ಆಫ್ ದ ಅಟ್ಮಾಸ್ಫಿಯರಿಕ್ ಕಂಡೀಷನ್ಸ್ ಲೈಕ್ ಏರ್, ವಾಟರ್, carbon dioxide etc. when they are reacting with iron rod, forming deposition of iron oxide on iron. Therefore, on the iron surface there will be surface phenomenon. Therefore, that is one of the surface reaction. Like that you can choose so many reactions in chemistry. That is heterogeneous catalysis. We come across heterogeneous catalysis. So, in heterogeneous catalysis so many industrial compounds are prepared in heterogeneous catalysis. So, in all those reactions this surface chemistry or surface phenomenon will be known. Okay. Now, in this surface chemistry, while discussing the surface matters, first of all you should know what do you mean by clear surface. How will you get clear surface? Namage surfaces clear agi yavaga sigutte anta. That means for getting clear surfaces you should provide high vacuum. Okay, high vacuum hege barutte? That means when a pressure of 10 power minus 8 to 10 power minus 9 Pascal, when a pressure of 10 power minus 8 to 10 power minus 9 Pascal is applied, then there will be high vacuum. So, when the substances are placed in high vacuum, then there will be ultra clean surfaces. High vacuum alli substances na ನೀವು place ಮಾಡಿದರೆ ಆಗ ultra clean surfaces ನಮಗೆ ಸಿಗುತ್ತೆ. When you remove the substance from high vacuum, again deposition of particles on that surface takes place. So, these are all the so many surface chemical phenomena we come across in our daily life. Now, in this chapter, surface chemistry chapter alli ನಾವು ಮೇಜರ್ ಆಗಿ 3 ಡಿಫ್ರೆಂಟ್ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ನಾವು ಸ್ಟಡಿ ಮಾಡ್ತೇವೆ. ಸೊ ಹಾಗಿದ್ರೆ ಆ 3 ಡಿಫ್ರೆಂಟ್ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಯಾವ್ದ್ಯಾವುದು ಅಂತ ನೋಡೋಣ ಈಗ. ಸೊ ಕಾನ್ಸೆಪ್ಟ್ ನಂಬರ್ 1, adsorption. Concept number 2, catalysis, and concept number 3, colloids. ಸೊ ಈ ಮೂರು ಇಂಪಾರ್ಟೆಂಟ್ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ನಾವು ಸರ್ಫೇಸ್ ಕೆಮಿಸ್ಟ್ರಿಯಲ್ಲಿ ಸ್ಟಡಿ ಮಾಡ್ತೇವೆ. ಸೊ ಬಟ್ ರೀಸೆಂಟ್ಲಿ ಫ್ರಮ್ ದ ಸಿಲೆಬಸ್ ಕ್ಯಾಟಾಲಿಸಿಸ್ ಕಾನ್ಸೆಪ್ಟ್ನ ರಿಮೂವ್ ಮಾಡಿದ್ದಾರೆ. ಸೊ ದೇರ್ ಫೋರ್ ನೌ ವಿ ವಿಲ್ ಬಿ ಸ್ಟಡಿಯಿಂಗ್ ಓನ್ಲಿ ಅಡ್ಸಾರ್ಪ್ಷನ್ ಆ್ಯಂಡ್ ಕಲಾಯ್ಡ್ಸ್ ಇನ್ ದಿಸ್ ಚಾಪ್ಟರ್. ಸೊ ಕ್ಯಾಟಾಲಿಸಿಸು ಚಾಪ್ಟ್ರಲ್ಲಿ ಇಲ್ಲ. ಸೊ now we will move on to adsorption. So what do you mean by adsorption? Adsorption is the phenomenon of accumulation of molecular species at the surface rather than in the bulk of solid or liquid. So definition I will write. It is nothing but accumulation of molecular species at the surface rather than in the bulk of solid or liquid. So see here, that is the definition. That means accumulation of molecular species at the surface rather than in the bulk of solid or liquid. See for example, there is a surface. So there is a surface. Now if the molecules are accumulated at the surface rather than in the bulk, then this phenomenon is called adsorption. So for adsorption to happen, there should be two substances. ಎರಡು substances ಬೇಕು ನಮಗೆ. What are those two substances ಅಂದರೆ, one is molecules or molecular species and another one is solid substance. This solid substance is also called as adsorbent. This solid substance or maybe liquid solid substance is called adsorbent and the molecular species is adsorbate. See here, there are two important substances required for adsorption. The substance or the surface on which the molecules are going to adsorb is called adsorbent, as well as the molecules which are going to adsorb on the surface is called adsorbate. So for example, take bread and put jam on it. Okay, so bread, if you put jam on it, what happens? Jam get adsorbed on surface of bread. So that is adsorption. Okay, like that. See, there is a duster. Duster is there. Now when this duster I will rub here, what happens? Chalk powder particles get adsorbed on duster. They does not go inside the duster. They only accumulate at the surface of the duster. So this is also adsorption. So adsorption occurs by two substances, adsorbent and adsorbate. So many examples of adsorption will come across in daily life. So ಅದಕ್ಕೆ ಎಕ್ಸಾಂಪಲ್ಸ್ ನೋಡಿ. ಈಗ ಟೇಕ್ ಎ ಕ್ಲೋಸ್ಡ್ ಕಂಟೈನರ್, ಒಂದು ಕ್ಲೋಸ್ಡ್ ಕಂಟೈನರ್ ತಗೊಳ್ಳೋಣ. ಸೊ ಇನ್ ದಟ್ charcoal will be there. So and gas molecules like oxygen, hydrogen, chlorine, sulfur dioxide, like that. If you take those gas molecules in a closed container containing charcoal, so what happens? If you measure the pressure of gas molecules decreases. Why in a closed container the pressure of gas molecule decreases? That is because of the phenomenon of adsorption. So only these gas molecules are going to adsorb on a surface of charcoal. So, therefore, that is one of the example of adsorption. Like that, another example, take a coloring substance dye like methylene blue indicator. So, methylene blue indicator, when this methylene blue indicator is shaken with animal charcoal, after filtration we get a filtrate with colorless solution. That filtrate will be colorless. Why? That is because animal charcoal adsorbs coloring matter present in methylene blue. So, that is also adsorption. So, like that you can give so many examples for adsorption. Now, we will move on to next concept, that is absorption and difference between adsorption and absorption. What do you mean by absorption? See here, this is AB, absorption. Idu adsorption, AD. Absorption means it is the phenomenon of accumulation or penetration of molecules into the bulk of the substance. That means molecules are going to accumulate or penetrate inside the bulk. Such phenomenon is called absorption. Hege, see here, there is a substance here. This is a substance. The molecules going inside like this. So, see here, molecules are going inside. That is penetration of molecules into the surface or into the bulk is called absorption. Whereas adsorption means only molecules are going to accumulate on the surface or at the surface. Whereas in case of absorption, molecules are going inside into the substance. For example, take bread and put that bread into coffee or tea. What happens? It get absorbed, absorption takes place there. That means coffee or tea get absorbed inside the bread. So, that is called absorption. So, absorption means bulk phenomenon, adsorption is surface phenomenon. So, now we will see the difference, because in the examination they will ask write any two differences between absorption or adsorption. They will ask any two difference. So, you should remember the differences between adsorption and absorption. So, what are all the differences between absorption and adsorption? All of you know, adsorption is a surface phenomenon. Adsorption is a surface phenomenon, whereas absorption is a bulk phenomenon. Absorption is a bulk phenomenon, whereas in case of adsorption, molecules are going to adsorb at the surface accumulation of molecules at the surface, whereas in case of absorption, penetration of molecules into bulk. So, that is second difference. Absorption or accumulation of molecules at the surface, here penetration of molecules into the bulk. Next difference is, in adsorption the concentration of molecules or particles is only at the surface. Concentration of molecules is only at the surface. Here concentration of molecules is uniform throughout. Concentration of molecules is uniform. So, concentration of molecule is uniform throughout the substance. ಹಾಗೆಯೇ ಅಡ್ಸಾರ್ಪ್ಷನ್ಗೆ ಎಕ್ಸಾಂಪಲ್ಸು ತುಂಬಾ ಕೊಡ್ಬೋದು. ನಾನು ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಮಾತ್ರ ಬರಿತೀನಿ. ಎಕ್ಸಾಂಪಲ್ ಫಾರ್ adsorption is adsorption of water vapor on silica gel. Adsorption of water vapor on silica gel is adsorption, whereas absorption of water vapor on calcium chloride, adsorption of water vapor into calcium chloride is absorption. So, silica gel if you take and put in the atmosphere, then it adsorbs water vapor present in the atmosphere, whereas if you put calcium chloride, it absorbs moisture or water vapors from the atmosphere. So, these are all the differences between absorption and adsorption. So, now there is a phenomenon called sorption. So, sorption andre enu? What do you mean by sorption? Sorption means if both adsorption and absorption takes place simultaneously. Adsorption and absorption phenomenon takes place simultaneously, then such type of reactions are called sorption. That is, such type of phenomenon is called sorption. Sorption is the phenomenon in which both absorption and absorption takes place simultaneously. Adsorption ಮತ್ತೆ absorption ಒಂದೇ ಟೈಮಲ್ಲಿ ಆದರೆ ಅದನ್ನು ಸಾರ್ಪ್ಷನ್ ಅಂತ ಕರಿತೀವಿ. ಅದಕ್ಕೆ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಕೊಡ್ತೀನಿ ನೋಡಿ. ಟೇಕ್ ಚಾಕ್ ಪೀಸ್ ತಗೊಳ್ಳಿ, ಪುಟ್ ದಟ್ ಚಾಕ್ ಪೀಸ್ ಇನ್ ಇಂಕ್, ಡಿಪ್ ಮಾಡಿ ಇಂಕಲ್ಲಿ, ಏನಾಗುತ್ತೆ? ಚಾಕ್ ಪೀಸ್ ವಿಲ್ ಬಿ ಬ್ಲೂ ಕಲರ್. ಇಂಕಲ್ಲಿ ಹಾಕಿದರೆ ಬ್ಲೂ ಕಲರ್ ಆಗ್ತದೆ. ಸೊ ಈಗ ನಾನು ಅದನ್ನು ಬ್ರೇಕ್ ಮಾಡ್ತೀನಿ. ಸೊ ಬ್ರೇಕ್ ಮಾಡಿದಾಗ inside that chalk there is no blue color, only solvent will be there and color will not be there, because here the ink or dye present in the ink get adsorbed on the surface of chalk, whereas solvent present in the ink go into the bulk. Therefore, here in this process both adsorption and absorption takes place simultaneously. ಒಂದೇ ಟೈಮಲ್ಲಿ ಅಡ್ಸಾರ್ಪ್ಷನ್ ಮತ್ತು ಅಬ್ಸಾರ್ಪ್ಷನ್ ಆಗುತ್ತೆ. ಸೊ ದೇರ್ ಫೋರ್ ದಿಸ್ ಫೆನಾಮಿನನ್ ಇಸ್ ಕಾಲ್ಡ್ ಸಾರ್ಪ್ಷನ್. ಹಾಗೆ ಅಡ್ಸಾರ್ಪ್ಷನ್ಗೆ ಆಪೋಸಿಟ್ ಒಂದು ಫೆನಾಮಿನನ್ ಇದೆ. ವಾಟ್ ಈಸ್ ದಟ್? ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಡಿಸಾರ್ಪ್ಷನ್. ಸೊ ಡಿಸಾರ್ಪ್ಷನ್ ಅಂತ ಫೆನಾಮಿನನ್. ಸೊ ವಾಟ್ ಡು ಯು ಮೀನ್ ಬೈ ಡಿಸಾರ್ಪ್ಷನ್? ಇಟ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ process of removal of adsorbate molecules from the surface of adsorbent. Adsorbate molecules na surface of adsorbent ಇಂದ ರಿಮೂವ್ ಮಾಡುವಂಥ ಫೆನಾಮಿನನ್ನ ಡಿಸಾರ್ಪ್ಷನ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ದಟ್ ಮೀನ್ಸ್ ಡಸ್ಟರಲ್ಲಿ ಡಸ್ಟ್ ಪಾರ್ಟಿಕಲ್ಸು ಅಡ್ಸಾರ್ಬ್ ಆಗಿದೆ. ದಿಸ್ ಈಸ್ ಅಡ್ಸಾರ್ಬೆಂಟ್, ದಿಸ್ ಈಸ್ ಅಡ್ಸಾರ್ಬೇಟ್. ಸೊ ಇಫ್ ಯು ರಿಮೂವ್ ದಿಸ್ ಅಡ್ಸಾರ್ಬೇಟ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಫ್ರಮ್ ಡಸ್ಟರ್, then that is called desorption. Removal of adsorbate molecules from the adsorbent, then this process is called desorption. So ಇದೆಲ್ಲನೂ ಕೂಡ adsorption phenomenon ಅಂತ ಹೇಳ್ತೇವೆ. ಸೊ ಈ adsorption phenomenon ಅಲ್ಲಿ ಯಾಕೆ adsorption ಆಗಬೇಕು? ವಾಟ್ ಈಸ್ ದ ರೀಸನ್ ಫಾರ್ adsorption? ಅದಕ್ಕೆ there is some thermodynamic reason. ಸೊ ಈಗ ಅದನ್ನು ನಾವು ಮುಂದಿನ ಇದರಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡುವ. Why adsorption takes place, that is mechanism of adsorption ಅಂತ ಹೇಳ್ತೇವೆ. ಸೊ ವೈ ಅಡ್ಸಾರ್ಪ್ಷನ್ ಟೇಕ್ ಪ್ಲೇಸ್, ಯಾಕೆ ಅಡ್ಸಾರ್ಪ್ಷನ್ ಆಗಬೇಕು ಅದಕ್ಕೆ ನಾನು ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಕೊಡ್ತೇನೆ ನೋಡಿ. ಸಿ ಹಿಯರ್ ದಿಸ್ ಎಕ್ಸಾಂಪಲ್, ಕನ್ಸಿಡರ್ ಆ್ಯನ್ ಅಡ್ಸಾರ್ಬೆಂಟ್ ಆರ್ ಸಾಲಿಡ್ ಸರ್ಫೇಸ್. ಅಡ್ಸಾರ್ಬೆಂಟ್ ಇದೆ, ಇಲ್ಲೆಲ್ಲ ಪಾರ್ಟಿಕಲ್ಸ್ ಇದೆ. So this is adsorbent. Now suppose consider a particle at the bulk. Consider a particle in the bulk. See here. Now this particle experiences forces in all directions. Nodi illi. That particle present in the bulk experiences forces in all directions, whereas suppose if you take a particle at the surface, what happens? This particle experiences force only in this direction, in this direction, in this direction, in this direction. So what happens this? Here there will be unbalanced forces. So here, here, here there will be unbalanced forces on that particle, on the surface. So that unbalanced forces are also called as residual forces. Unbalanced forces are residual forces. Due to this residual force or unbalanced force present on the surface, there will be more in surface energy. Surface energy ಜಾಸ್ತಿ ಆಗುತ್ತೆ. So due to more surface energy, what happens is adsorption takes place. Because of surface energy, that is nothing but surface tension. Surface tension will be there. ನೀವು ಫಸ್ಟ್ ಪಿ ಯು ಸಿಯಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡಿರ್ತೀರಾ ಸ್ಟೇಟ್ಸ್ ಆಫ್ ಮ್ಯಾಟ್ರಲ್ಲಿ. ಸೊ ಸರ್ಫೇಸ್ ಟೆನ್ಷನ್ನಿಂದ, ದಟ್ ಸರ್ಫೇಸ್ ಎನರ್ಜಿಯಿಂದ ದೇರ್ ವಿಲ್ ಅನ್ಬ್ಯಾಲೆನ್ಸ್ ಫೋರ್ಸಸ್ ಇರೋದ್ರಿಂದ ಅಡ್ಸಾರ್ಪ್ಷನ್ನು ಅಟ್ ದ ಸರ್ಫೇಸ್ ಆಗುತ್ತೆ. ಸೊ ಅಟ್ ದ ಸರ್ಫೇಸ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಅಕ್ಯುಮುಲೇಟ್ ಡ್ಯೂ ಟು ದ ಅನ್ಬ್ಯಾಲೆನ್ಸ್ಡ್ ಆರ್ ರೆಸಿಡಿಯಲ್ ಫೋರ್ಸಸ್ ಪ್ರೆಸೆಂಟ್ ಅಟ್ ದ ಸರ್ಫೇಸ್. ಸೊ ದಟ್ ಈಸ್ ಸರ್ಫೇಸ್ ಎನರ್ಜಿ. ಸೊ ಆಫ್ಟರ್ ಅಡ್ಸಾರ್ಪ್ಷನ್ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್? ಈಗ ನಾವು ಅಡ್ಸಾರ್ಪ್ಷನ್ ಯಾಕಾಗತ್ತೆ ಅಂತ ತಿಳ್ಕೊಂಡ್ವಿ. ಬಟ್ ಅಡ್ಸಾರ್ಪ್ಷನ್ ಆದ ನಂತರ ಆಫ್ಟರ್ ಅಡ್ಸಾರ್ಪ್ಷನ್ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್? ಆಫ್ಟರ್ ಅಡ್ಸಾರ್ಪ್ಷನ್ ದಿಸ್ ಸರ್ಫೇಸ್ ಎನರ್ಜಿ ಡಿಕ್ರೀಸಸ್. ಸರ್ಫೇಸ್ ಎನರ್ಜಿ ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ ಆಫ್ಟರ್ ಅಡ್ಸಾರ್ಪ್ಷನ್. ಮಾಲಿಕ್ಯೂಲ್ಸು ಅಕ್ಯುಮುಲೇಟ್ ಆದಾಗ ಸರ್ಫೇಸ್ ಮೇಲೆ ದಟ್ ಸರ್ಫೇಸ್ ಎನರ್ಜಿ ಡಿಕ್ರೀಸಸ್, ಕಡಿಮೆ ಆಗುತ್ತೆ. ಸೊ ದಿಸ್ ಡಿಕ್ರೀಸ್ ಇನ್ ಸರ್ಫೇಸ್ ಎನರ್ಜಿ ಈಸ್ ಲಿಬರೇಟೆಡ್ ಇನ್ ದ ಫಾರ್ಮ್ ಆಫ್ ಹೀಟ್. ಡಿಕ್ರೀಸ್ ಇನ್ ಸರ್ಫೇಸ್ ಎನರ್ಜಿ ಈಸ್ ಲಿಬರೇಟೆಡ್ ಇನ್ ದ ಫಾರ್ಮ್ ಆಫ್ ಹೀಟ್. ಹೀಟ್ ಎನರ್ಜಿಯಾಗಿ ಲಿಬರೇಟ್ ಆಗುತ್ತೆ. ಸೊ ದೇರ್ ಫೋರ್ that liberated heat energy is called as heat of adsorption. Heat energy evolution ಆಗುತ್ತೆ. So that phenomenon is called heat of adsorption. In thermodynamics first PUC ಯಲ್ಲಿ ಎಲ್ಲರೂ ಎಂಥಾಲ್ಪಿ ಕೇಳಿದ್ದೀರಾ. So enthalpy is nothing but heat. Here heat of adsorption means amount of heat liberated or evolved when adsorption takes place, or during adsorption how much heat is liberated or evolved is called heat of adsorption. So that means heat of adsorption is delta H change in enthalpy. Heat of adsorption, that is surface energy decreases, heat is evolved, therefore enthalpy becomes negative. Why it becomes negative? Heat is liberating. Heat is liberating means delta H value will be negative. So therefore which type of reaction is this adsorption? Heat is liberating means it is exothermic reaction. Those reactions in which heat is liberated, they are called exothermic reaction. Those reaction in which heat is absorbed reactions are called endothermic reactions. During adsorption, heat is liberated, therefore enthalpy of adsorption is an exothermic reaction. Adsorption phenomenon is an exothermic reaction. So, delta H negative. Now, does this adsorption is spontaneous or non spontaneous? Spontaneous ಅಥವಾ non spontaneous ಅಂತ ಹೇಗೆ ನೋಡೋದು ನಾವು ಅಂದರೆ, for that we should consider two more values. One is delta S and another one is delta G. That in thermodynamics chapter ಅಲ್ಲಿ first PUC ಅಲ್ಲಿ ನೀವು ಕಲ್ತಿದ್ದೀರಾ, Gibbs free energy equation. So, those reactions in which delta G becomes negative, such reactions are spontaneous ಅಂತ ಹೇಳಿದ್ದೀವಿ. Now, adsorption spontaneous non spontaneous ಅಂತ ನಾವು ನೋಡೋಣ ಈಗ. See here, delta S for adsorption ಏನಾಗುತ್ತೆ? What happens to the delta S? S, what do you mean by S? That is entropy. S is nothing but entropy. What is entropy? It is the degree of disorderness or randomness of a system. See, there is a adsorbent here, adsorbent is there and adsorbate molecules are here. Now, during adsorption what happens? These molecules, they get accumulated at the surface. So, ಈ ಥರ accumulation ಆಗುತ್ತೆ. So, due to that, here entropy will be more. When accumulation takes place, adsorption takes place, the molecules are arranged on the surface, therefore entropy will be less. That means disorderness is in the order gaseous molecules greater than liquid greater than solid. So, therefore, for gaseous molecules randomness is very high, whereas for liquids and solids randomness is lower. Therefore, here during adsorption what happens? Randomness decreases because of the accumulation of molecules. So, randomness decreases, that means change in entropy what happens is become negative. Randomness decreases, then entropy becomes negative. Now, delta H negative, delta S negative, then now what is the value of delta G? Delta G value na nodbekandre, we will go for free energy equation. So, free energy equation ge hogona. So, what is that equation? That is delta G is equal to delta H minus T delta S. Okay. ಈ ಈಕ್ವೇಷನ್ನ ನೀವು ಫಸ್ಟ್ ಚಾಪ್ಟ್ರಲ್ಲಿ ಸಿಕ್ಸ್ತ್ ಚಾಪ್ಟ್ರಲ್ಲಿ ಎಲ್ಲಿಂಗ್ಹ್ಯಾಮ್ ಡಯಾಗ್ರಾಮ್ ಅಂತ ಕೇಳಿದ್ದೀರ. ಸೊ ಎಲ್ಲಿಂಗ್ಹ್ಯಾಮ್ ಡಯಾಗ್ರಾಮ್ ಇನ್ ಜನರಲ್ ಪ್ರಿನ್ಸಿಪಲ್ಸ್ ಆ್ಯಂಡ್ ಐಸೋಲೇಷನ್ ಆಫ್ ಎಲಿಮೆಂಟ್ಸಲ್ಲಿ ಆ ಎಲ್ಲಿಂಗ್ಹ್ಯಾಮ್ ಡಯಾಗ್ರಾಮಲ್ಲಿ ಈ ಒಂದು ಈಕ್ವೇಷನ್ನ ಕಲ್ತಿರ್ತೀರ. ಸೊ ದಟ್ equation is called free energy equation. So, here for adsorption the value of delta H is negative and minus T into the value of delta S is negative. Okay. Therefore, the equation becomes delta G equals minus delta H plus T delta S. So, ee tara equation bartade. Now, according to this equation, delta G becomes negative only when T delta S is less than delta H. When T delta S less than delta H, then delta G is negative. So, therefore, adsorption phenomenon is spontaneous when the value of T delta S is less than delta H. That means, at lower temperatures adsorption is spontaneous. As the temperature increases, adsorption decreases. Therefore, as the adsorption continues, the value of surface, that is heat of adsorption, goes on decreasing. That means the value of delta H goes on decreasing, becomes equal to T delta S. So, there is a condition where the value of delta H becomes equal to T delta S, then delta G becomes equal to 0. So, what is that condition called? Chemical equilibrium, that is equilibrium. You chemical equilibrium chapter alli odidira. So, state where delta G is equal to 0, that is equilibrium state. So, aga equilibrium exist agutte. So, this is the thermodynamics of adsorption or mechanism of adsorption. So, adsorption is an exothermic reaction and adsorption is spontaneous at lower temperatures. As the temperature increases, adsorption decreases. So, idishtunu navu mechanism of adsorption alli ಕಲ್ತ್ಕೊಂಡಿದ್ದೇವೆ. ಸೊ ಇಲ್ಲಿ ಅಡ್ಸಾರ್ಪ್ಷನ್ ಯಾಕೆ ಆಗುತ್ತೆ ಅಂದರೆ ಬಿಕಾಸ್ ಆಫ್ ದ ಸರ್ಫೇಸ್ ಟೆನ್ಷನ್. ಕ್ವಶನ್ ಕೇಳಿದರೆ 1 ಮಾರ್ಕಿಗೆ ಎಕ್ಸಾಮಲ್ಲಿ ನಿಮಗೆ. ಸೊ ವೈ ಅಡ್ಸಾರ್ಪ್ಷನ್ ಆ್ಯಪನ್ಸ್ ಅಂತ ಕೇಳಿದರೆ, ದಟ್ ಈಸ್ ರೀಸನ್ ಈಸ್ ಬಿಕಾಸ್ ಆಫ್ surface tension or because of the residual forces or the unbalanced forces present at the surface. So, idu mechanism of adsorption. There are two important types of adsorption. They are physisorption. This is also called as physical adsorption, and another one is chemisorption. Physisorption and chemisorption. So, what is this physisorption? What is chemisorption? Andre, in physisorption there will be weak van der Waals forces of interaction between adsorbent and adsorbate. Adsorbent matte adsorbate molecules na naduve weak forces irutte. Weak van der Waals forces are there. Weak van der Waals forces are there between adsorbent and adsorbate. Adsorbent matte adsorbate naduve weak van der Waals forces irutte. So, that is physisorption. Whereas, what is chemisorption? If there is a strong chemical bonds between adsorbent and adsorbate, strong chemical bonds formation agidre, that is chemisorption. So, strong chemical bonds between adsorbate and adsorbent, then that is chemisorption. So, ee physisorption it is not so specific. Yake ನಾನು ಆಗಲೇ ಹೇಳಿದಾಗೆ ಡಸ್ಟ್ ಪಾರ್ಟಿಕಲ್ಸು ಡಸ್ಟರ್ ಮೇಲೆ ಕೂತ್ಕೊಳ್ಳುತ್ತೆ, ಚಾಕ್ ಪೌಡರ್ ಡಸ್ಟರ್ ಮೇಲೆ ಕೂತ್ಕೊಳ್ಳುತ್ತೆ. ಇಫ್ ಯು ಪುಟ್ ಸಮಥಿಂಗ್ ನೀವು ಇದ್ರ ಮೇಲೆ ಹಾಕಿದರೆ ಅದೆಲ್ಲ ಕೂತ್ಕೊಳ್ತದೆ. ಸೊ ಇಟ್ ಈಸ್ ನಾಟ್ ಸೋ ಸ್ಪೆಸಿಫಿಕ್. ಅಂದರೆ ವೀಕ್ ವ್ಯಾನ್ ಡರ್ ವಾಲ್ಸ್ ಫೋರ್ಸಸ್ ಇರುತ್ತೆ ಅದರಲ್ಲೆಲ್ಲ. So, there will be weak van der Waals forces between adsorbate and adsorbent, hence this is not specific. But chemisorption is highly specific. Why chemisorption is highly specific? Because in chemisorption only few adsorbent molecules and few adsorbate molecules get adsorbed on adsorbent. So, this is highly specific in nature. So, physisorption is not so specific, whereas chemisorption is highly specific in nature. Similarly, in case of physisorption, it is reversible. Physisorption is reversible, whereas chemisorption is irreversible. Why this happens? Physisorption, due to the presence of weak forces, adsorbent and adsorbate can be broken and again they can be accumulation takes place. But in case of chemisorption, due to the formation of strong chemical bonds, this chemisorption can't be reversed. Reverse ಮಾಡಲಿಕ್ಕೆ chemisorption ಆಗಲಿಕ್ಕಿಲ್ಲ because of the bond formation ಆಗುತ್ತೆ in chemisorption. So next, in case of physisorption, heat of adsorption is very low. ನಾಗಲೇ ಹೇಳಿದೆ, heat of adsorption is low, very low, that is 20 to 40 kilojoule per mole. Heat of adsorption is nearly 20 to 40 kilojoule per mole, whereas in chemisorption heat of adsorption is very much greater, that is 80 to 240 kilojoule per mole. Here, due to the strong chemical bonds, the heat of adsorption is 80 to 240 kilojoule per mole. So during adsorption, that much amount of heat is liberated. And finally, in case of physisorption, it is multi-molecular layered adsorption, whereas chemisorption, it is monomolecular layered adsorption. ಯಾಕೆ ಅಂದರೆ ಫಿಸಿಸಾಪ್ಷನ್ನು ನೀವು ಡಸ್ಟರಲ್ಲಿ ಬೋರ್ಡ್ನ ಎಷ್ಟು ಸರಿ ರಬ್ ಮಾಡ್ತೀರೋ ಅಷ್ಟು ಕೂಡ ಚಾಕ್ ಪೌಡರು ಚಾಕ್ ಪಾರ್ಟಿಕಲ್ಸು ಅಬ್ಸಾರ್ಬ್ ಆಗ್ತಾನೆ ಹೋಗುತ್ತೆ. ವೆರಾಸ್ ಇನ್ chemisorption, once the reaction takes place at the surface of adsorbent, then further no reaction. That means physisorption is multi-molecular layered adsorption. Multi-molecular layered adsorption, whereas chemisorption is monomolecular layered adsorption. Multi-molecular layered adsorption is physisorption and monomolecular layered adsorption is chemisorption. So now in the examination there will be question on this, that is write any two differences between physisorption and chemisorption. 2 mark ಈ ಕ್ವಶನ್ ಕೇಳ್ತಾರೆ. ಸೊ physisorption and chemisorptionಗೆ ಎನಿ ಟೂ ಡಿಫರೆನ್ಸಸ್ ನಿಮಗೆ ಹೇಳಿ ಅಂತ ಕೇಳ್ತಾರೆ. ಸೊ ನೀವು ಯಾವುದಾದ್ರೂ ಎರಡು ಡಿಫರೆನ್ಸಸ್ನ ಯು ಶುಡ್ ರಿಮೆಂಬರ್. ಓಕೆ, ದೇ ವಿಲ್ ಬಿ ಡೆಫಿನೆಟ್ ಕ್ವಶನ್ಸ್ ಆನ್ ದಿಸ್ physisorption and chemisorption difference. So write any two differences between physisorption and chemisorption. So these are the types of adsorption. So next concept, adsorption isotherm. In first PUC, all of you have studied isotherms, isobars and isocores. So what is isotherm? Isotherm is the graph platted at constant temperature. ಹಾಗೆಯೇ ಐಸೋಬಾರ್ ಅಂದರೆ ಗ್ರಾಫ್ ಪ್ಲಾಟ್ ಅಟ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಪ್ರೆಷರ್, ಐಸೋಕೋರ್ ಅಂದರೆ ಗ್ರಾಫ್ ಪ್ಲಾಟೆಡ್ ಅಟ್ ಕಾನ್ಸ್ಟೆಂಟ್ ವಾಲ್ಯೂಮ್. ಸೊ ನಮಗೆ ಈಗ ಬೇಕಾಗಿರುವಂಥದ್ದು ಐಸೋಥರ್ಮೋ. ದಟ್ ಮೀನ್ಸ್ ಹಿಯರ್ graphs are plotted at constant temperature. So see, adsorption isotherm. So what do you mean by adsorption isotherm? Adsorption isotherm means it is nothing but the relationship between amount of gas adsorbed on an adsorbent with pressure at constant temperature. So that is called adsorption isotherm. Adsorption isotherm is a graph plotted between amount of gas adsorbed versus pressure at constant temperature. So that is adsorption isotherm. That is the relationship between amount of gas adsorbed on adsorbent versus pressure at constant temperature is called adsorption isotherm. In this adsorption isotherm, there will be two isotherms. One is Freundlich adsorption isotherm, another one is Longmuir adsorption isotherm. But in your syllabus, only Freundlich adsorption isotherm is there. So now we will be going to that Freundlich adsorption isotherm. So, Freundlich adsorption isotherm. What is this Freundlich adsorption isotherm? Freundlich is a scientist. In 1909, he gave an empirical relationship between amount of gas adsorbed on an adsorbent versus pressure at constant temperature or at a given temperature is called Freundlich adsorption isotherm. That means it is the empirical relationship between amount of gas adsorbed per unit mass of an adsorbent with pressure at a given temperature is called Freundlich adsorption isotherm. So, I will write the definition first. Freundlich adsorption isotherm is the empirical relationship between amount of gas adsorbed per unit mass of an adsorbent with pressure at a given temperature is called Freundlich adsorption isotherm. So, mathematically this can be written as mathematical expression. Mathematically, x by m is equal to k into p power 1 by n. See here, this is the mathematical expression of Freundlich adsorption isotherm. So, where this x by m is amount of gas adsorbed per unit mass of adsorbent, amount of gas adsorbed per unit mass of adsorbent. K and n are constants and P is pressure. So, this equation is when n is greater than 1. So, here x by m is the amount of gas adsorbed per unit mass of adsorbent and K and n are constants, P is pressure. So, this is the Freundlich adsorption isotherm. Now, if we plot this x by m versus pressure, how the graph will look? See here, I will take x by m here and pressure here. When plotted, graph will look like this. So, I have written 3 graphs at various temperatures. This graph is at 195 Kelvin temperature, this graph is at 244 Kelvin temperature and this graph is at 273 Kelvin temperature. So, see here, there are 3 different graphs at various temperatures. So, according to this graph, as temperature increases, what happened to the adsorption? See here, adsorption decreasing. As temperature increases, adsorption decreases. So, as pressure increases, adsorption increases. So, amount of gas adsorbed increases with increase in pressure, whereas adsorption decreases with increase in temperature. So, therefore, that is the graph of Freundlich adsorption isotherm. Now, is this Freundlich adsorption isotherm is valid? How to check that one? Freundlich adsorption isotherm ಸರಿ ಇದೆ, ವ್ಯಾಲಿಡ್ ಆಗಿದೆ ಅಂತ ಹೇಗೆ ಚೆಕ್ ಮಾಡೋದು ಅಂತಂದರೆ, ಫಾರ್ ದಟ್ ಯು ಹ್ಯಾವ್ ಟು ಟೇಕ್ log on both sides for this equation. Then if you plot the graph between log of this and log of that, then if you get a straight line curve, straight line graph, then that will be the proof for the Freundlich adsorption isotherm. So, if you take log, that is log x by m is equal to log k plus log 1 by n log p. So, see here, this equation resembles y is equal to c plus mx. ಎಲ್ಲರೂ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಅಲ್ಲಿ ಕಲ್ತಿರ್ತೀರಾ equation of a straight line. See here, this is similar to the equation of a straight line. This is variable y, this is a constant c, and this is a constant and a variable. So therefore, now if you plot graph between log x by m versus log p, then the graph will look like this. Log of x by m versus log p, then the graph will look like this one. So there is a straight line with slope equal to 1 by n and the intercept is log k in ABC. So see here, this is a straight line curve, straight line graph with slope 1 by n and intercept log k. See here. So this resembles equation of a straight line. Therefore this is the proof for Freundlich adsorption isotherm. Therefore Freundlich adsorption isotherm is valid. Followed all of you. So that is about adsorption isotherm.